Hi everyone, welcome to this new video. In today's video, we're going to work with an example in which I'm going to showcase how to use the Python flavor to log custom models or custom classes. So the example is under the folder examples. It's called multimodel. So the idea is to train a classifier that consists of multiple, let's say, models, machine learning models. And we're going to log that particular class using the Python flavor. So under this folder, multimodel, we have like multiple Python scripts. We have this entry point in which I defined two functions that will serve as entry point for this project. So the first function is train multimodel. The task of this function is to train the model and log it with MLflow. So let me walk you through this code. So the first thing that we can see here is get trained and test data method. So let me show you the definition of this particular function. Here you can see that we are using make classification, and this method is coming from scikit-learn to create like a demo dataset, because here the focus is how to use or how to log custom definitions for models. So with make classification function, we can build a dataset. In this case, since we are working with a classifier, it has to be a classification problem or classification dataset. Then I am creating some names for the columns, the feature columns. And here I am transforming that into a data frame, a pandas data frame. Finally, I am using train test split from scikit-learn to split my data into training and testing data. Back to the entry point. So here we can see that we are creating an instance of this multi-classifier class. So let me show you the definition. The first thing that you can notice here is that we are using the Python model as a parent for this class, which allows us to log this model or this class use the Python flavor. Well, what we are logging is an instance of this class. So in the init method, we are specifying some algorithms that we want to use and a dictionary with models. So we're going to save the models under this dictionary. Then let's say train estimators method. Well, this method takes the training data and then iterate over the available models and train each one of the models. Right? So here I'm using this method self.getModel, which is very simple. It returns a random forest classifier if the algo is equals to random forest, or it returns the decision tree classifier if the algo is decision tree. So once I trained my model using the fit method, I save the model in the dictionary. So let's see the predict method. Here, we have the predict method that we're going to use to get the predictions. So you can notice here that the first thing that we are doing is that we are evaluating if this variable self.algot exists. This variable is coming from the context. So if I show you this method, load context, you can see that here I am getting, or I am defining self.algo from the model configuration, right? So I am accessing the model configurations in the context of this model to get the algo, let's say parameter, right? But let's say that if this parameter doesn't exist, the value is going to be known, right? And that's why here I have like a second conditional that says if self.algo is known, well, it means that the algorithm was not found in the context, right? And that's why here what I'm doing is, hey, now let's take a look at the parameters that you can see here. Does the algo parameter exist in the parents dictionary, right? If not exists, I'm going to create basically this default value, random forest, which means that When I load back the model, if this algo variable doesn't exist, I'm going to use by default random forest. Then finally here, I decide which algorithm to use or which model by using the self.algo variable and then getting the predictions. So back to the entry point. Okay, after creating an instance of my classifier, I use the train estimators method to train my multi-classifier. Then I set the tracking URI for MLflow. I specify a name for the experiment that I want to use. I use this method to create the experiment if it doesn't exist, or get the experiment if it's already there. Then I set an experiment tag, mlflow.nodeContent, and as you know, this represents the description of the experiment. Then we specify the signature using this method, getModelSignature. So notice that here I am passing this dictionary that represents the parameters. So let me show you how I am building this signature in this function. GetModelSignature is here. The first thing that I'm doing is to create an input schema for the inputs or the features and output schema for the output of the model, which is very simple. We have just to provide the name and the type of the column. Then I'm going to create this list, input parameters, and use the parent specification object to create the specification for my parameters. I just had to provide the name of the parameter, the data type, and a default value. And as you can see here, I am building this list from this parents parameter that it's coming from the inputs of this particular function. Finally, I create a parent schema object using this class parent schema, which is coming from MLflow. I provide the input parameters, which is a list with param specifications, and then I return the model signature object. Okay, back to the entry point. Finally, here we are starting the MLflow run. I provide the ID of the experiment that I want to use as a container for this run. I set some run tags. For example, the model type is a multimodel, and mlflow.node.content. And as you know, this represents the description of the MLflow run. Here I create this registered model name because I want to register this model automatically in the model registry. So since we are logging an instance of a class, a custom class, we need to use the Python flavor, right? I provide the artifact path for the model, the Python model, which is the instance of the class, the signature, input example, the registered model name to register and create a new version of the model in the model registry, and then this model configuration dictionary, right? Then here what I'm going to do is to load back the model, right? So I build the model URI, then I create an evaluation dataset and use the mlflow.evaluate method to run some evaluations. So here I pass the model URI for the model, the evaluation dataset, the name of the column that contains the targets or the labels, the model type, in this case is a classifier, the evaluator config, right? Well, this is a special dictionary that we can pass to provide additional configurations to the evaluators. In this case, I am using this configuration called metric prefix. The idea is that with this configuration, MLflow will append this, let's say, prefix to each one of the metrics that mlflow.evaluate calculates. And finally, model config. In this case, it's just a dictionary with the parameter algo and the particular algo. So this parameter is coming from the top of the function here, right? I have an option. I have two options, right? I can pass the algorithm when I am running the script in the CLI, and or maybe I just don't provide that value and use this one by default, random forest. So let me run this train multimodel. If I go to the poetry project, pipe project toml, we can see that we have this entry point, train multimodel. This is the name of the entry point, and this is the path. Examples.multimodel.entrypoints train multimodel. If I follow this path, I'm going to get to this function, right? Which means that if I want to run this function, I need to use poetry run and then train multimodel. Now I'm not going to pass any, let's say, parameter right now, which means that the script will use the default value for the algorithm, which is random forest, as you can see here. So it's validated input sample. Okay, it seems that the training process was completed. Random forest is being used. The model already exists in the registry, so MLflow just created a new version. It's the version 20 at this point. And right now it's performing the evaluations. Predicting with model random forest. So right now MLflow is running some evaluations, right? And while it's trying to get predictions, it's using this method, right? The predict method, as you see. And here, what you can see here is predicting with model is this line, right? So let's wait a bit more for the results. So it's taking a bit of time, and this is probably because of the permutations that it has to do to calculate the feature importance. But if I go to the UI, I can show you some results right now. So here, if I go to multimodel, for example, I have this run that is still like running right now. It's running, as you can see here. But if I go to artifacts, I can show you that we already have some metrics, like the evaluation confusion matrix. We have the multimodel with the input example. What else? If I go to overview, yes, we already have some metrics. And as you can see here, all these metrics, now they have this prefix, eval, because I specified this in the configuration. And I also provided the or log this value as a parameter, algo. So we know that this run or this model was trained, was logged using the random forest, I mean the evaluations in this case. Because remember that we are training two models, the random forest classifier and the decision tree classifier. But these particular evaluations were performed using the random forest classifier. So now if I go to overview, okay, it's still running. Okay, it's finished, right? So here we can see all the artifacts. We can see the explainer for this model. And we have like the feature importance plots for these models. So we can see that, for example, the feature 1 seems to be relevant for this classifier. And well, that's all for this video. In the next video, I'm going to show you how to load the model back and get predictions, right? Using the next entry point, which is going to be inference multimodel. Well, that's all for this video. Thanks for watching it, and see you next time.